Hello, Matthews Gatos here. We're going to do page 326, number 11. Okay, so we have two sides of a triangle that are 6 and 8 meters in length. The angle between them is decreasing at a rate of 0.035 radians per second. We want to find the rate at which the area is decreasing when the angle is pi over 6. So this is a related rates question. So let's get a triangle just as a little sketch. Definitely not meant to be drawn to scale. So I have one side that is 6 meters and another side that is 8 meters, and the angle between them I'll call theta. Now it's decreasing at a rate, so that's d theta by dt is decreasing, so negative 0.035. I want to find the rate that the area is changing when theta equals pi over 6. Okay, so that's my specific value. I don't use that until after I've taken the first derivative. Okay, so what I want to do is look at area. So if I drop down a perpendicular line segment here, that is the height. I want to come up with an expression for area. So area is base times height divided by 2. I want to have this in terms of theta. Well, my base I already know is 6. So 6 times height divided by 2. 6 divided by 2 is 3. So it's just really 3 times my height. But I want my height in terms of theta. So let's look at my triangle. I have an opposite over a hypotenuse, which is sine. So sine of theta is opposite over hypotenuse. Times both sides by 8. And I get 8 sine theta is equal to height. So I'm going to use that for my height. So area is going to be 3 multiplied by my height, which is 8 sine theta. So area 24 sine theta. Okay, let's take the derivative of that with respect to time. So take the derivative of both sides with respect to time. So I'll end up getting dA by dt equals 24. The derivative of sine is cosine theta, and the derivative of theta with respect to time, d theta by dt. So I want to know the rate at which the area is changing when theta equals, let's go back up here, when theta is pi over 6. And the rate of change of the angle was negative 0. What was it? 0.035. Okay, so dA by dt is equal to 24 times. Now, cos of pi over 6. Pi over 6 is a nice point on the unit circle. The point on the unit circle for pi over 6 is root 3 over 2.5. So cosine is root 3 over 2 times by negative 0.035. Okay, so dA by dt is equal to, well, 24 divided by 2 is 12. So I'm going to have 12 root 3 multiplied by this number here. So I'm going to need to go to my calculator to come up with an answer for that. So let me just go into my calculator and we'll enter in, what was it? It was 12 square root 3. Oh, let me try that again. Let's clear that out. So 12 square root of 3. And then I'm going to multiply that by negative 0.035. And there we go. So the rate of change of the area, let's just copy that over. I can paste that, bring it down. So, oops, this is the rate of change of the area. Let's just get some units going on here. The units are meters. Okay, and then the time is seconds. So the rate of change of the area, let's write that down there, dA by dt is equal to, not equal to, I changed my mind, approximately negative 0.73 meters squared per second. I'm doubting myself. Is that my units? Yeah, meters squared per second. That would be the rate of change of area. So I hope that that one helped, and I'll see you for the next question.